Have you ever wondered what's actually happening on your screen when you're just, say, dragging a window around? It seems so simple, but behind that smooth motion is an incredibly complex and lightning-fast process that makes everything you see on your computer possible. Today, we're going to pull back the curtain and demystify the magic of computer graphics. To make this easy to understand, let's use a logistics analogy. Imagine your screen as a massive grid, and each tiny point of light on it is called a pixel. Think of each pixel as a minimum cargo box. Every single one of these little boxes needs to be filled with specific information, its color and its brightness. Millions of these boxes make up the single image you see at any given moment. So who fills these boxes? That's the job of the rendering pipeline, which is like a super efficient assembly line inside your computer's graphics card, or GPU. This assembly line takes raw data about a 3D scene like in a video game or the layout of your desktop, and processes it step by step. It figures out the geometry of objects, where they are in the virtual space, how they're lit, what textures they have, and finally, it calculates the exact color for every single pixel or every cargo box on the screen. Once our assembly line has filled all the cargo boxes for one complete image, what we call a frame, where do they go? They're moved into a special area of memory called the frame buffer. You can think of the frame buffer as the finished goods warehouse. It holds one complete, ready-to-display frame, all packed up and waiting for shipment. The warehouse is perfectly organized, holding the exact color information for every pixel from the top left corner of your screen to the bottom right. Now, how do these finished goods get delivered to you, the customer? That's where the monitor comes in. The monitor's refresh rate is like the number of shipments per second. If you have a 60 Hz monitor, it means it's asking the warehouse for a new shipment 60 times every second. The GPU sends the entire frame from the frame buffer to the screen, which then lights up all the pixels according to the new instructions. This happens so fast that your brain perceives it as smooth, continuous motion rather than a series of still pictures. So let's go back to our simple example, dragging a window across the screen. When you click and drag, you're sending a constant stream of new commands to the computer. With every tiny movement of your mouse, you're telling the operating system, the window is now here. For each of these new positions, the rendering pipeline has to recalculate the entire scene. It figures out what's behind the window, what the window itself looks like, and what the desktop background is. It then fills all the millions of pixel cargo boxes with the updated color information. This new frame is placed in the frame buffer, and at the next refresh cycle, it's sent to your monitor. This whole process calculating the new image, filling the buffer, and displaying it happens dozens or even hundreds of times per second. That's why the motion looks so fluid. If your computer is slow, it might not be able to fill the cargo boxes and update the warehouse fast enough to keep up with the monitor delivery schedule. This is when you see stuttering or lag. The monitor is asking for a new frame. But the warehouse is empty, so it just displays the old one again. To make things even smoother, modern systems use a technique called double buffering. Instead of just one finished goods warehouse, they have two. While the monitor is displaying the image from warehouse A, the assembly line of GPU is busy preparing the very next frame and storing it in warehouse B. As soon as warehouse A is done, the system instantly switches to displaying the frame from warehouse B. Now, warehouse A is free to be filled with the next frame after that. This prevents the screen from showing a half-finished image, a phenomenon known as screen tearing, and ensures a constant, smooth flow of visuals. Think about a high-end gaming session. The GPU isn't just moving a window. It's calculating the position of your character, the actions of enemies, the physics of a bouncing grenade, complex lighting, shadows, and reflections. It has to do all of this and then paint a brand new, multi-million pixel masterpiece from scratch, over 100 times every second. It's an incredible feat of computation. Every frame is a snapshot in time, a complete painting that exists for just a fraction of a second before being replaced by the next one. This brings us to a fascinating question. We've talked about how images are created and displayed in real time. But when you save an image to your computer, like a screenshot or a JPEG file, what are you actually saving? Is it the raw 3D model data? Is it the instructions for the assembly line? Or is it something else entirely? Think about it. The final image on your screen is just a fleeting moment in a constant stream of data. So what information gets captured and stored permanently on your hard drive? We'll dive into that topic in a future video, exploring file formats, compression, and how we turn these temporary frames into permanent data. It's another amazing part of the digital world we interact with every day. So next time you're playing a game or just browsing the web, take a moment to appreciate the incredible, high-speed logistics operation happening right before your eyes. Thanks so much for watching, and if you enjoyed this look behind the screen, be sure to like, subscribe, and hit that notification bell so you don't miss our next video. See you then.